We're here today visiting the University of Surrey at the invitation of Emily Farran, Professor in Developmental Psychology and Director of the Cognition, Genes and Developmental Variability Lab. Emily is Principal Investigator of a new research project called Make Space, the Value of Spatial Reasoning for Mathematics, which has just been launched. Spatial reasoning has the potential to reinvigorate the way we teach children, all kinds of subjects in the curriculum, and improve mathematical understanding, attitudes, inclusion and attainment. Spatial reasoning is the ability to understand the spatial properties of objects such as their size and location, and to visualise objects and problems in the mind. We're here to discover more about this important project. So Emily, thank you very much for having us here at the University of Surrey. Are you able, first of all, to tell us a little bit about your sort of background and your interest in psychology, sort of why psychology?
Yeah, so I did my undergraduate degree in psychology, and I really enjoyed the research part of the degree. So I did my dissertation actually in areas quite similar to this. So I was interested in spatial working memory for my undergraduate dissertation, and I just felt like I wanted to do more. So I did my PhD, so both my undergraduate and PhD were at the University of Bristol.
So can I just, spatial working memory, that's different to working memory. That is a combination of retaining...
So working memory has a number of different parts to it. So verbal working memory, you have the central executive, you have the visuospatial part. And so visuospatial working memory is very much about the location of items and that kind of holding in mind things that are sort of visual or spatial in terms of the objects and their locations.
Really fascinating. And that was because you personally had an interest in finding a way around in the world, or?
I think at Bristol there was a really big working memory group. And so I went to a lot of the seminars there, and a lot of the seminars were from exciting sort of international speakers who were coming to Bristol to tell us about the latest research in that area. And so I was very much influenced by that. And then I carried on with my PhD, and that's when I became very interested in intellectual disability. And so I worked during my PhD on spatial abilities in children and adults with Williams syndrome, which is a genetic syndrome. And I've also worked with people with Down syndrome. At that point, we were looking at large-scale spatial abilities, so the ability to navigate, partly because adults with these sort of genetic syndromes don't often manage to find jobs and be able to be independent of their parents. And we wanted to be able to think about how much of that is being able to just get somewhere and being able to find your way from A to B without getting lost. So we worked for a long time in the real world looking at navigation, but also I did quite a lot of virtual reality work to investigate navigation. And that was while I was at Reading, University of Reading, and then at UCL as well. And then while I was at UCL, I was at the Institute of Education, so I was getting more influence from educators. I was also part of the Centre for Educational Neuroscience when it launched, and I still am. And that's where I started to get a bit more interested in spatial reasoning in primary school and what it is, a sort of process, what it supports. So spatial reasoning is a number of different skills. They can support many different types of attainment. And my work more recently has focused on the relationship between spatial reasoning for science and spatial reasoning for mathematics.
So if we sort of move on, I suppose, and we got to Surrey University, which is where we currently are, and you're CogDev, DevCog. It's which one is it? It's CogDev.
CogDev,
and in that capacity as director of CogDev, have you been able to hone in a bit more detail on these more specific areas of spatial awareness?
Yeah, so I mean, I started the CogDev lab about 15 years ago. So that was when I was at UCL, and then moved it to the University of Surrey. And in fact, we now have a co-director, Debbie Gooch, who you're going to be talking to later on. And there was a very exciting time in my lab when we really started to get our teeth into the kind of spatial maths research. So I had a number of PhD students all at the same time who were excellent PhD students who were all working on trying to better understand this relationship between spatial ability and mathematics. So that was Katie Gilligan-Lee, and spatial ability in science. So that was Alex Hodgkiss. And there were many other very good PhD students at the time. And we started by looking at just associational data. So, if you measure someone's spatial skills and you measure their mathematics or their science skills, are those children that are better at spatial ability also better at mathematics or science? And we were finding repeatedly that was the case. So there was a really strong association between those two things. And that gave us the sort of evidence base to then think about interventions, and that's where I am now, thinking about interventions.
So winding back ever so slightly, I'm a geographer by training, obviously have an interest in psychology, etc. now. So tell me a little bit more. So for me, spatial awareness is I stand with a map and try and figure out where I'm going, north, south, east, west. Can you give a sort of layperson's view about what we mean by spatial awareness and why it's so important for, let's say, maths development?
So spatial awareness or spatial reasoning or spatial thinking or spatial cognition, there's lots of different terms that are used almost interchangeably. They're subtly different, but we can use them, all of those terms. It describes a collection of skills, so it's not just one thing. So we can think about one kind of spatial skill, which is about an understanding of object properties, so understanding the shape and the size, the location of objects, and the relationships between objects, so how far away I am from you, me being able to kind of navigate around the room and without bumping into things is a kind of understanding of my own spatial, space that I take up. Then we have other skills, and I think a really key spatial skill for mathematics is the ability to visualise. So this is not just being able to have a kind of picture in your head. It's the ability to manipulate things in your head. So
we are still talking about objects, or are we talking about hard conceptual equations? Or?
Well, it can be either. But in terms of a sort of easy example, it is just if you're stacking a dishwasher and you're thinking about, okay, I want to get that cup in, but I might need to move things around in order to fit it in. You might think about it in your head before you actually do it.
Loading the boot of a car after a Sainsbury's shop.
Absolutely.
Shouldn't say Sainsbury's, but could be any other.
Absolutely. So it's that kind of ability to manipulate things in your head. But you might use that in mathematics problems as well. So you might be rearranging a formula in your head. So that's where you've kind of got, it's less object-based, it's more of an abstract thing. Or you might have these, children are often presented with mathematical word problems. So Johnny has 7 apples that kind of thing. So being able to sort of actually think about if somebody takes 2 of the apples, like actually think about that in your head and understand it from a sort of visualizing point of view. And then the other kind of spatial skill, or less of a spatial skill, but we use a lot of tools to support our spatial reasoning. So you talked about geography, so we use a map, that's a spatial representation of our world. We also use things like spatial language. So in order to kind of understand spatial concepts, we're developing spatial language, and we use that for communication. So there's easy words that young children will be learning, like on and in and next to. But then as children get older, words like parallel, ascending, all of these sorts of words are really supporting children's spatial concepts. And you can see that I started to gesture then. So gesture, again, is something, we can talk about things being wider or narrower.
Over there.
Exactly.
Up
there. Yes.
So one of the things I think that excites us a lot from a learner's point of view is you have very specifically engaged in applying the research that you have undertaken over the last 20 years or so. And you've sort of applied it very specifically to early years up to primary. I don't know if you've gone into secondary particularly. And we have on the table a few things that you have started to develop. Are you able to tell us a little bit more about space, for example, and certainly the early childhood maths group as well?
No, absolutely. So the space project is something that...
That's this one?
So that's the space project.
And this?
These are part of the spatial reasoning toolkit.
Okay.
This is part of the space project.
Okay.
So what we wanted to do in the space project, so as I said, when I started...
It's not sponsored by Lego by any chance?
No, it's not sponsored by Lego, but involves a lot of Lego.
Perfect.
But what I wanted to do... we'd done a lot of research where we demonstrated this association between spatial ability and maths, and then we'd done a number of interventions where we'd gone into schools, we'd taken children out one-on-one, taught them some spatial skills, and then shown that by doing that their mathematics improved, which is, it's a really exciting thing to demonstrate.
So were teachers not doing this beforehand? Is that
well,
or they didn't know that they needed to? Or?
The curriculum doesn't specify that teachers need to be teaching spatial reasoning. It's a foundational skill for mathematics.
Yes, absolutely.
And children will use spatial strategies, but it's not explicitly taught in schools. And there's a few reasons for that. So, I mean, in 2021, the early years foundation stage has a number of early learning goals, and there used to be one for space, shape and measure. And in 2021, that was removed. So that's problematic for a number of reasons. One, it means that we don't really have a strong record of those children's foundational spatial skills as they go through school. So you don't know what their sort of starting point was. But it also, unfortunately, means that it's not really something that's prioritised, because the teachers know they're not going to be assessing it. Not necessarily through their own fault, but it's just not prioritised either at senior leadership team level or the teachers level.
Limited amount of time. If you're not told you
absolutely.
don't need to do it, don't do it.
So it's not really taught. Also, geometry is an area of mathematics which is very, very spatial. But there was an Ofsted report where they showed that teachers reported they often leave geometry to the kind of end of summer term. And one of the recommendations from the Ofsted report was that it needs to be interspersed throughout the year. But even when you look at the geometry curriculum, given all those spatial skills that I just talked to you about, the geometry curriculum is quite shape and space focused. There's absolutely nothing about visualisation, but yet, you know, the huge body of evidence demonstrates that visualisation is really, really important for mathematical problem solving. And so, that's where we have a bit of an issue. So this is where the space project came in. I was really keen that I didn't just do lots of research and it never actually got to the teachers. Absolutely. So I wanted to run something that was something that could be scaled up for use in the classroom. So this is sort of a starting point. So the space project was a 6-week training project. The teachers received professional development so that they kind of understood the evidence base. They received lots of prompting.
This is from nursery up to, or are we?
Well, this was for year 2 children.
Okay.
So this was 6 to 7-year-olds.
Right.
And based on that professional development, the teachers had the agency to use not just the space material that we gave them, but to understand why spatial reasoning is important for mathematics. So part of that, we produced these prompt cards. So in the professional development, we taught the teachers to sort of understand where spatial reasoning comes in. Here you'll see lots of different spatial reasoning skills. So we've got visualisation there, which we've talked about before, spatial scaling, representation, so the fact that lots of representation of data is spatial. When you look at a pie chart, when you look at a bar graph, it's a spatial representation. And then the visual and spatial memory, composition and decomposition. So what we've got on these prompt cards are, on one side, where that particular spatial skill might be seen in a Lego session, so one of the space sessions. But then, crucially for us, we wanted to connect it to mathematics. So on the other side, we've got a scenario in mathematics where the same spatial skill might be seen.
Very clever.
And that was where we wanted the teachers to understand that this isn't just an add-on, it needs to be part of mathematics. So for us, we started with these space sessions.
So did you then develop from here? You developed these...
Yes, this
which has just been launched, isn't it?
Separate project. So this was working with the Early Childhood Maths group, who are a wonderful, wonderful group. Obviously, I'm a psychologist, and I try and sort of make sure that I talk a lot to people who know about teaching and know about maths education. So because there's a really strong evidence base for this relationship between spatial ability and mathematics, we wanted to make sure that there was awareness of that evidence base. So we decided to put together a toolkit. So the toolkit includes a guidance document which has sort of accessible sort of explanation of different kinds of spatial skills and what the research tells us. And in that as well is a developmental trajectory. So children, it shows children's development from birth to 7 years in a number of different spatial skills, how the adult can support the development of those skills and what you might need in the environment. So if you're doing an obstacle course, for example, you might want the children to have access to planks and hoops and tunnels. And if you want to develop their spatial language while they're doing the obstacle course, you might want to get them to narrate their way around the obstacle course. So saying, I'm going up, I'm going over, I'm going through. So we had lots of different examples through this developmental trajectory. And then these things in front of us here are other examples. So we've got different age ranges here.
So you've got the under three, and then
4
3
to
to
5,
4, 4 to 5, and
yeah.
6 to 7.
And
you have these, which
we have
amazing.
these key rings. So in all of these, there's examples of activities that you might be doing already.
Yeah.
So we're not asking teachers to buy new things or to sort of do extra, but we're asking them to think about the activities they're doing already and how they can make them more spatial. So there's quick sort of references here in terms of the posters and the key rings.
So these posters, for example, tell teachers that these are some of the things that they need to do and how to do them.
Yeah, and then we've got spatial language that they might want to use in the boxes here as well.
So can I ask, are you engaged with the curriculum planners and the policymakers as well, or is it just, I say just, it's the teachers as well?
I'm trying to.
Okay.
So when there are opportunities to submit evidence, so there's often calls for evidence, and I always submit something when it's relevant to the work that I'm doing. So we're in the middle of a curriculum and assessment review, so I've submitted evidence to that curriculum and assessment review. So we will wait and see what the outcome is. I also...
It did sound like Ofsted had started to understand that actually there's too much of a gap between what they would like to happen and what actually is happening.
Well, I think there's a lot of movement actually, so I'm very hopeful about the curriculum and assessment review. So just in the last few years, there's a good number of policy documents where spatial reasoning is really quite central to that document. So Ofsted have talked about the importance of spatial reasoning and number for early years. There's the Royal Society asked myself and some of the early childhood maths group to write an expert panel opinion. So we've published that with the Royal Society on spatial reasoning. And then more recently, the Maths Horizons, that was a report that was published on Sunday, and they have been referencing our work and talking a lot about spatial reasoning, and they do talk about knowledge progression and having an understanding of knowledge progression in different areas. And so that brings us back to the trajectories that we've been developing. And actually some of the feedback that we had from the toolkit was, why haven't you gone to the end of primary school years? And that was just a practical decision because I was working with the early childhood maths group, but now a few of us have extended that.
Sorry to interrupt, I was going to sort of bring that up. You haven't referenced secondary schools, for example. Is it because there's almost a window of opportunity to develop this skill, and once it's closed at the age of 10 or 8 or whatever, that's it? Spatial awareness as a skill is something that can be acquired, and it has to be acquired early on, or you're never really going to be able to develop it, or am I just
Do you know what's
fishing
amazing? It works at any age.
Oh, wow.
So there's been research with 14-year-olds from Tom Lowry's group in Australia where they've been teaching children in terms of visualisation and improving their maths abilities. And some of the earliest work was Cheryl Sorby on engineering undergraduate students. So what she found is that there was a problem with engineering in that there was too much dropout. So the students that had signed up to the engineering course didn't all make it to the end. And so what they did...
These are undergraduates?
Undergraduate students.
Right. Even that old.
Yeah, and so they developed a spatial module which they made the kind of lowest achieving students take. So they measured their spatial skills. The lowest, whatever, percentile of those students took this spatial module. And as a result of taking that spatial module, throughout the degree, they got better grades and there was much less attrition from that degree. And in fact, that module has just been, or that model has just been replicated in Glasgow. So there's a group in the computer science department in Glasgow who have used a spatial reasoning module for their computer science students and again shown this sort of increase, not just in their spatial skills, but throughout their degree. So any age.
The other thing I would say, which comes across as being a little bit obvious, but from a teacher's point of view, is this specifically for primary schools? You're saying possibly no. And then is it specifically for maths teachers? I mean, dare I say it, but what happens to the historian, for example? Or, I mean, assuming that they need an understanding of time. Yeah. And I suspect they need. Is it something that could be inculcated all the way through the curriculum?
Yes, it could be. So as part of our Royal Society work, we have got a case study for geography and a case study for design and technology, but it is much broader than that. There just isn't the research in every single area. And if you just think of different sort of STEM careers, you can think about geologists having to map timelines, you can think about biologists having to read DNA images and diagrams, you can think about neuroscientists having to understand MRI scans. So all of these are kind of spatial representations of information. And even if you think about chemistry and the periodic table, the way in which that is arranged, the sort of chemical relationships is arranged in a spatial way. In the same way on a ruler, the ordinal relationship of numbers is arranged in a spatial way. So yeah, I mean, it's much broader than mathematics.
So you've based all of this wonderful stuff here on, I should imagine, very conclusive evidence. Can you tell us a little bit about that, how robust it is? Yeah,
no, absolutely. So we're now at a point where there's enough evidence that people are starting to do meta-analyses. So, you know, there was a meta-analysis in 2013 by David Utall and his colleagues, which kind of really boosted the volume of research that was happening. So there's a huge amount of research happening now between looking at this understanding of the relationship between spatial ability and maths. But in the last couple of years, there were two meta-analyses that I think are worth mentioning. One was to look at the relationship in terms of associations between spatial ability and mathematics by Atti et al. And they demonstrated that across 45 different studies that had asked about this relationship, it was a really strong and consistent finding across genders, across age ranges, that children who are better at spatial ability are better at mathematics.
Dare I ask if they are better at science as well, or better at DT?
I know she's writing a meta-analysis at the moment. I haven't read it, but so from a science point of view, that is coming. There's less research in that area. And then the other meta-analysis, which I think is really key to the work that I've been doing, was one that was specifically asking about the causal relationship. So if you train children in their spatial abilities, do they get better in not only their spatial abilities, but their mathematics abilities? And this was published in 2022 or 2023 by Hawes et al. And they demonstrated across 29 studies that, yes, if you train children's spatial abilities, there's a really robust finding across all of these different studies that has a positive impact on their spatial abilities and their mathematics abilities. And in fact, what they were able to show at the primary school level, which is the level that I'm kind of working at, is that the spatial training, the impact on mathematics was the equivalent to about half of a year of development in mathematics skills. So it's a really kind of important finding. And just this understanding that this is something that we can train is really key to the research that I'm doing.
So it leads me on to asking where to next. I mean, you've done so much. You have done so much research. I'm assuming now you're quite excited about, obviously, taking this out there. It has been launched, so people can connect with this organisation. But where is your the CogDev lab going next?
There's two things I'm really interested in.
Just the two?
I
bet there's more, however.
So space was a kind of isolated intervention where children were building Lego blocks, and there was a certain amount of embedding because the teachers had the prompts as to how to spatialise their mathematics teaching. But I would like to do an intervention which is very much taking the current content and spatialising it and see whether I would predict that would have an impact on children's mathematics abilities. The other thing I'm really interested in is what we've found from all of our spatial reasoning work is that it's really inclusive. So some of the findings from the space study were that some of the groups that maybe are more left behind in other sort of areas of the teaching content were able to keep up. So children with English as an additional language, children who had maybe been labelled as kind of low achievers, really got on well with the space programme. So I'm very interested in a better understanding of the impact of spatial reasoning training on the sort of diversity within the classroom and understanding how universal it is for all children, because I think that it is something that is very universal for all types of learners, and I would like to do a bit more research on that.
Well, I have to say, on behalf of learners and on behalf of me as a teacher, this is wonderful work. I really, really value the fact that you have taken the research and you're applying it in a way that is definitely easy-ish to understand from a practitioner's point of view. So really, really, really wonderful. And thank you very much once again for inviting us over. It's been absolutely fascinating to talk to you. And maybe I can come back in 5 years' time.
Yeah, absolutely.
We can do some catching up and find out where we've gone.
Yeah.
So thank you very much.
Thank you.
Thank you very much for joining us, Debbie. Can you give us a little bit of info about your background and why psychology? I'm assuming it was psychology.
Yes, so I did my PhD in psychology at the University of York with Maggie Snowling and Charles Hume, and I was focused on exploring the co-occurrence between dyslexia and ADHD, with a particular focus on understanding time perception and executive function, as well as phonological skills in those two neurodevelopmental conditions.
And then you left York University and continued the research elsewhere, or you came straight to Surrey?
So I actually stayed at York for a postdoc, so I worked on the Wellcome Language and Reading Project, which is a longitudinal study and a family risk study, so looking at children at family risk for dyslexia and also children with early language difficulties, and we followed those groups over time to explore the similarities between those groups and the differences, and to understand better the predictors of children's outcomes.
And you then came to the University of Surrey, where you are now...
Nearly. So I first, after that, so I did another postdoc.
You've been very busy.
Yeah, lots of research positions. So another postdoc down at Royal Holloway and later at UCL with Professor Courtney Norbury. So this was on the Surrey Communication and Language and Education Study, which again was another large-scale project, a population study looking at language in the early school years, and trying to understand how many children start school with a developmental language disorder, what that looks like, and how those children progress through the school years. So the latter part of that study looked at social emotional outcomes of that group as well as educational outcomes. And then I came to Surrey in 2017 as a lecturer in developmental psychology.
And you joined the co-director of the CogDev
CogDev Lab last year.
So at the moment, some of the work that you're doing, we have been talking briefly about some of the work that the CogDev Lab has done from a spatial awareness point of view. Yeah. Are you able to tell us a little bit, because I understand that you're one of your strands, I think, is that you are looking at the impact of the relationship, I suppose, between spatial awareness, maths, and cultures other than UK-based Western European cultures.
Yeah, that's right. Because I think I joined the CogDev Lab because Emily and I have sort of complementing skill sets, and I'm really interested in language development and how that plays a role in maths outcomes, and also how neurodevelopmental conditions like dyslexia and maths difficulties co-occur and what underpins that. So we're both sort of cognitive developmental psychologists, so had shared interests. And had the opportunity for Alexandra Zebra from Brazil. She's at the University, Mackenzie University in São Paulo in Brazil, came as a visiting scholar, and it opened up another collaboration opportunity for us all. And so we're now involved in a cross-cultural or cross-country study between Brazil and the UK to explore spatial reasoning and how it's important in mathematics development in those two countries. So we have that non-Westernized view as well, and data from that country.
Anything to report yet, or is that still...
It's still early days. So the data were collected from about 400 children in Brazil and 400 children over here in the UK. And we've done some initial sort of exploration of the data. We can see that we can measure spatial reasoning well in both countries, as we know, and we can see that it's associated with maths performance concurrently. And we're also hoping to have a look at social economic status within both of those samples to see whether that influences the relationship between spatial reasoning and maths outcomes.
To be published few years' time?
Yeah, a few years' time. So data analysis and writing over this summer.
Okay.
So yeah, watch this space for that one. But what's really nice about this study is that this data was collected as a pre-test for an intervention that the Brazil team are running anyway.
Okay.
And Emily and I were involved in developing an active control condition for that intervention to make sure that it's a robust test of the effectiveness of a reading and executive function intervention. And that active control condition involves a lot of spatial reasoning and mathematical tasks. So it's a way of sort of piloting and trying whether that is effective in the children in Brazil. And we have measures of spatial reasoning and maths as outcome measures for that intervention, so we can see if that control condition has any influence on those as well later on. And perhaps in the future looking to develop that as a full intervention.
I will be watching this space in a couple of years' time.
Yeah, so it's big work in progress, but it's great to have that collaboration.
So your own work, though, as you say, is more to do with language and language acquisition. Are we primary school? Are we secondary school? Are we both?
To date, mainly primary school. The Scales project followed children with DLD and children without language difficulties into secondary school. And so we know that language is fundamental for educational attainment. We also know from the literature that language interventions are effective and can improve children's outcome if we identify children early. So I guess my main message for teachers is to ensure that there's a rich language environment and that acts as then a foundation for other academic skills, such as reading and maths as well.
So I suppose from a language maths point of view, there's an awful lot of language in maths questions, an awful lot.
Absolutely.
And if you misinterpret, can't read them, or... Yeah, I mean, you are never going to be able to understand what the question is asking, and I suspect something similar would happen in science as well. There will be a lot of language that can be interpreted in all sorts of different ways.
So language and reading are a massive barrier to maths and science outcomes for children. And I've actually got a PhD student who's interested in the overlap between reading and maths in the early school years. So he's currently recruiting children who are at risk of difficulties. We don't necessarily know yet if they've got maths difficulties or reading difficulties, but in the early primary school years. And looking at spatial reasoning and number knowledge, magnitude, understanding, as well as language and executive function to see how they predict children's maths and reading outcomes.
And anything to do with science?
Not at the moment in that study, but perhaps in the future that would be something really interesting to have a look at.
So sort of finally, I suppose, the direction of travel really for the CogDev lab and yourself. You're very happy at Surrey University. It's
really
a fantastic
happy.
University.
Yeah, fantastic university, and I think the lab provides an amazing community of practice. We have researchers at a range of stages in their career, all the way from placement students to dissertation students. We have some research assistants and then more senior researchers in the lab, so that we can share knowledge, ideas, we can provide academic challenge and collaboration. So it's a really nice, rich place to do our research.
As a lab, you work quite closely, I presume, with local schools and obviously in Brazil, further afield?
Yeah, local schools, PhD students will recruit from all over. So I have another PhD student as well, Ivana Dorica, who's doing a very different project looking at social emotional mental health in adolescents with reading difficulties. So it links in with my work slightly separately from Emily's work, but again, understanding those outcomes for adolescents. This is an under-researched area. Most of that research to date has focused on children. And actually, we want to understand, well, we know that adolescents or people with reading difficulties are at risk of poor mental health outcomes and poor wellbeing outcomes. But we don't yet know why that is. So there's an assumption that it's because of them facing barriers, because of their reading and language difficulties, but actually there could be many other explanations for that. So there could be shared risk factors between these neurodevelopmental conditions and wellbeing outcomes. There may be family level, school level factors that will promote better wellbeing as well.
You have a lot to unpick.
So there's lots to unpick in that project.
A lot to do. No wonder you're going to be committed to it. Yeah. It's been absolutely lovely, wonderful meeting you. Thank you very much for your contributions, and yes, good luck in the future.
Thank you very much.
Thank you. Katie, thank you very much for joining us. Lovely to meet you. Can you tell us a little bit about your background and I think why psychology? What is it about psychology that's fascinated you or interested you?
Yeah, so I'm a research assistant currently with Emily and Farran here in the CogDev lab, and I'm working on the MathMind project. But before that, I was an undergraduate here actually at Surrey.
You're at Surrey University?
Yeah, so I did
You've made your way around this really, really difficult to get around campus.
Yeah, it's quite complex, but you get used to it.
Yeah.
So I did my psychology degree here, and during I had a placement year where I actually worked with Emily in research, and I worked on, she probably talked a bit about it, at the Blocks and Space project during my placement year.
She didn't actually. So what was the Blocks and Space project?
Oh, it's all about, we were looking at Lego interventions and how they best...
Space project, yes.
The Space project, yes. And then she became my supervisor for my dissertation. And then she mentioned when I graduated, oh, there's a role sort of opening up in MathMind, and if I'd be interested. And I was like, definitely, because I sort of found a bit of a niche in an interest in children's math development and spatial development, and I've really enjoyed working here.
So your interest is in maths and therefore spatial development, or spatial development and therefore maths, or just the two together?
Sort of just the two together. I think I'm most interested in how we can use sort of spatial reasoning and things like that to better maths development in children.
So are you able to, you're heavily involved now as a research assistant in MathMind. I know it's an ongoing project, but are you able to tell us a little bit about maybe the origins, how it sort of, what inspired it, and a little bit about exactly what you were doing?
Yeah, so the MathMind project is all about mathematical inclusion for neurodiversity.
Oh, that's the mind.
Yeah,
yes.
And it's a collaboration between Emily here at Surrey, Professor Guy Sarif at Oxford, and also Professor Jo van Herwegen at UCL. And its main focus is just to better understand the thinking skills that lead to strong numeracy and development in children with genetic syndromes across sort of all of primary school. And
specific
also,
genetic syndromes? Are you looking at any in particular? Or?
Yeah, we're looking at 3 specific ones. Okay. So we're recruiting children with Down syndrome, Williams syndrome, and also Fragile X syndrome.
Okay.
And we're sort of focused on those because they have an early diagnosis, so we can watch them all the way through primary school and see how numeracy develops.
As early as nursery school, or?
We're looking at 4 to 9-year-olds, so from reception up to year 5 and them going into year 6.
Okay. And are you able to say exactly what the hypothesis sort of is? What was it that you are trying to do, or what is it you're trying? You're engaged in a bit of therapy, a bit of intervention, are you? Or?
No, so we're sort of just trying to map the pathway of numeracy learning, sort of how these skills develop and what sort of school environments best support good maths development in these children.
That's a lot of data.
It's a lot of data. It's a big data collection project.
Wow, yeah. Crikey. And you're longitudinally going to follow them from 4 to 9?
No, so we longitudinally just follow children at time 1, and then a year later we follow them up.
Okay.
So if we see a child in reception, we'll see them again in year 1. If we see a child in year 5, we'll see them again in year 6.
And again, are you going to have time to see them again in year 2 or in year 3? Or?
No, so we're only following a child up once.
Okay.
But because we're seeing kids at all ages across primary school, we're going to have a lot of data that will tell us about the entire trajectory through primary school.
Do you have any theories about what you're going to find?
I have a few sort of my own theories just from being the data collection person and going in and things. But I think at the moment we're sort of at a level where we're just interested to see what's going to happen, sort of what environments are best supporting these children, especially things like one-on-one contact with TA support and also materials that are given to them by the schools.
So from a research point of view, do you go in and sort of observe what's happening first of all, record all of that, and then ask them to undertake, I presume, some set tests? Yeah,
so I actually go into the school and observe a maths lesson and just see what a child does on their typical day-to-day maths learning. And then I will do a set of maths sort of based assessments and also spatial reasoning, executive function, to see how all of these skills sort of interplay.
And you're clearly loving it.
Really like it, yeah, it's great.
And you're clearly wanting to stay in research.
Yes, I'd love to
Is it PhD next, or?
Sort of, who knows? I'm sort of at that stage where I'm finding working in schools really exciting, interesting, and just research itself is just fascinating.
Wonderful, wonderful. Well, really lovely to meet you, and thank you very much for your contributions.
Great, thank you.
Sarah, lovely to meet you, and thank you very much for giving up your time to talk to us today. Might I start by asking a little bit about your background and how you ended up at the University of Surrey as a researcher in the psychology department?
Sure. So actually I've been at Surrey for nearly 3 years. and I started here as a master's student doing my psychology conversion, and then I've worked in the lab as a research assistant, and now I'm doing my PhD in psychology.
Dare I ask where you came from before 3 years ago? What were you doing?
So actually, for the first 20 years of my working life, I've worked in financial services, in investment management, focused on marketing and communications, and then actually I had a career break and spent around 8 years at home, but also doing lots of voluntary work, including being the chair of a multi-academy trust in South West London.
Wow, big responsibility.
Yeah, it's a big voluntary role. But one that I was really committed to, and actually it really sparked my interest in understanding how we can actually develop strategies to improve educational outcomes for all children. And that's what's really directed my research over the last 3 years.
Wonderful, wonderful. So a nice little, I suppose, segue into what we are is an organisation called Learnus, and Learnus we want to try and build bridges between the practitioners and the academics. Are you able to take me through your involvement in the early childhood maths group and these wonderful resources that have been developed, I believe, in response to what the practitioners themselves wanted, and you as the academics listened and came up and developed these wonderful resources?
Yeah, I mean, they are absolutely really lovely resources.
They are.
And we've had really positive feedback from practitioners about how useful they are in terms of using them in the classroom. And I guess that's why we developed them. So stepping back slightly, I worked with Emily as a research assistant, looking at the impact of the spatial reasoning toolkit. So the toolkit was developed between Emily.
That was this, was it? These things.
That is where the posters
okay.
Have come from. So the spatial reasoning toolkit is a developmental trajectory running from birth to 7 years, and although it's just been extended from 7 years to 11 years, so it covers all of primary. Basically what it does is it gives ideas for practitioners about how spatial reasoning develops and what are appropriate activities at different age ranges within that 0 to 7
And you developed these 4 posters? So we've got...
they're from the toolkit. The posters were developed to give an idea for practitioners working in different rooms as to what's an appropriate activity at 3 to 4 years or 5 to 6 years. And then actually I ran some impact research, and we listened to the feedback of practitioners who'd used the toolkit for a year. And actually, you know, we all know that we don't read long documents, or that is a huge investment of time. And actually what practitioners need, particularly when they're working in the classroom, are snapshot reminders that can reinforce their practice. And so we developed these key rings based on the idea that you often see practitioners with pictures on their lanyards when they're working with children with additional needs, for example. And these were really just meant to distill all of the content that's in a 54-page document into something that's really easily referenced.
It's a fantastic idea. And you have them separated into 3 different categories, I believe. Is that true?
So breaking down...
So you've got shape, this one is movement and navigation, and this one is shape, composition and construction.
Absolutely. So depending on what you're working on, whether it's in continuous provision or as part of the curriculum, you can choose the one that is appropriate at that time, and then depending on which age group you're working with, it details all of the things that you can do. And practitioners told us that was particularly important because it might be that some children are not working at age-related goals. They might be working, below that or above that, and actually by including all of the developmental steps, it allows them to help children progress no matter where they are on that trajectory.
These are specifically for spatial awareness skills, I suppose.
Yes.
But I believe your own line of research isn't just about spatial awareness. Can you take us through a little bit about what sort of research you're currently engaged in? And you're part of the CogDev lab, is that true? Okay.
Yeah. Yes, I'm part of the CogDev lab, and Emily and Debbie are my supervisors. And my research is looking at how we can improve the maths attainment of children from low socioeconomic backgrounds using spatial reasoning. So it really is about bringing together and understanding better the relationship between socioeconomic status and maths, and how spatial reasoning impacts that.
Is there some sort of insight, for want of a better term, that people from different socioeconomic backgrounds have different experiences, I suppose, of the beginnings of spatial awareness skills?
Yeah, so I think what we know from research is that a child's socioeconomic status impacts their maths outcomes. And for example, if you were to look at the SATs results, so at the end of primary school, what you see is that children from low socioeconomic backgrounds, generally around 59% of them achieve the expected standard in maths at 11. And that's compared to 79% of their high socioeconomic peers. That's a huge gap.
Huge.
And we know that that is something that educators and policymakers are really interested in. How do we close that attainment gap? We also know that spatial reasoning directly relates to maths. So how good your spatial skills are will contribute to your maths understanding. And there's some evidence, although it's a small body of literature at the moment, that suggests that children from low socioeconomic backgrounds have lower spatial skills and that they benefit more from spatial training than their high socioeconomic peers. So what I'm interested in is, can we understand that relationship better? And can we develop an intervention or ways to help practitioners deploy spatial strategies to support children in terms of developing their math skills. Now, this will be of benefit for all children, but hopefully is an academic strategy that can contribute to closing that attainment gap.
And you're specifically interested in maths and spatial, or are you also interested in literacy, or are we now broadening it too much at the moment, and this is for, future ideas?
Yeah, so I think it's really interesting. I think there's probably 2 points I'd make. The first is that my research, my current study that we've just concluded, I included language within my analysis, and that was recognising, how much attention is paid to language within the curriculum and at an early age. And what was really interesting from the results I found is that a child's spatial skills was as important as their language skills to contributing to their maths understanding.
Wow.
So, we've invested, a huge amount in phonics and literacy, and actually the evidence suggests that we need to be doing the same for spatial reasoning, because that really impacts children's maths skills. And that was at age 2, age 4 and age 9.
And which elements of spatial reasoning are we thinking about now, or is it everything to do with spatial awareness?
So the spatial measures I was looking at actually were quite widely, were quite a wide range of spatial skills. So a child's block building skills at age 2 impacted their maths outcome at age 10. How well they could match shapes and recognised difference in shapes at age 2 contributed to their maths at age 9, at age 10. And things like puzzles at age 4. And then looking at things like reasoning and visualisation at age 9 hugely contributed to their maths understanding at age 10. So it was across a wide range of spatial skills, which is really interesting. But particularly one of the strongest was block building at age 2.
I've got this sort of face which sort of is suggesting you've got a lot now to continue your research into. What does the future hold for you? Are you going to continue with all of this?
Yeah, absolutely. I think for me, having completed my first study and really being able to identify more the mechanisms behind the relationship between spatial reasoning, maths and socioeconomic status, the next step is to work with practitioners. So I'm really interested in co-producing my research with practitioners, recognising that socioeconomic status is a complex issue, and it's not necessarily just about academic strategies or about providing breakfast. There's lots of different elements that need to be in place in order for those children to succeed in education. And I think it's really important that we do research hand in hand with practitioners in the classroom. So that's the aim, is to co-produce an intervention project with practitioners that hopefully will provide strategies that can be deployed in the classroom to help close this maths attainment gap.
A lot of work for future Sarah, an awful lot of work.
It's exciting.
Very exciting.
It's really exciting.
Yeah, very exciting. Dare I ask whether or not you're going to move into the secondary sector as well?
So I think at the moment my focus is on primary and particularly early years. We know that it's at that stage that interventions can have a greater impact. And so for me, I think it's all around, how much impact can we make? Because we know that if we leave it till secondary school, actually the gap has widened so much by that stage. If we can intervene earlier, then hopefully that changes the trajectory for those children.
Sarah, thank you very much for your time. It's been so interesting talking to you about it. And I look forward to continuing to, be involved at the University of Surrey. Maybe come back in 5 years' time and find out what else you've come up with.
Thank you.